Hello everyone, welcome to the fourth video in the series of building effective agents. In the past three videos, we have understood different types of workflows, which includes prompt chaining, then parallelization workflow. Then in the last video, we understood about the routing and other types of workflows. Now, what we are trying to do over here, like I've discussed in the previous videos as well, is that we are trying to declutter the space of building effective agents and trying out examples of different kinds of workflows as well as agents. So this is the last part of the series, and obviously we are taking examples from this article by Anthropic of building effective agents. The link and the link of the code will be attached in the description to the video, so don't really worry about that. We'll just try and understand how this particular kind of workflow, that is the Evaluator-optimizer Workflow, works, and in which situations we are going to use this workflow. So first we are going to understand what is this Evaluator-optimizer Workflow, and then we will move on to the agents, which is the last part of this article. As you can see, what is agents and when can this be used. So what happens in the Evaluator-optimizer Workflow is that a LLM call is given to an evaluator that has been built. This evaluator evaluates the result generated by the large language model based on certain specific criteria, and then it gives the feedback and the result to this generator if it is not of the accepted criteria. Now this is a loop over here, and the evaluator again evaluates and gives the rejected call plus the feedback, and then again the LLM comes with a refined output, and until the result is accepted, it will always go in a loop, and once it is of the required quality, or if it is about the required it passes the evaluation criteria, the result is accepted over here. All right, so this so let us understand it by say we have given a call to the large language model to generate a particular type of essay which is directive and which is striking on a particular kind of opinion, and we have clear criteria to evaluate that essay. So say the essay should be say 200 words long only, and the essay should not have any sort of political inclinations. So these are basic evaluator criteria that can be given to the large language model. And in the first iteration, when the LLM generates the result, if it does not pass that criteria, then it is again rejected and sent to the call generator, wherein it again works on that piece and then gives the result. So until unless it is accepted, the result is not coming out. So it is a loop over here. So we'll understand this through a basic example wherein a joke is generated, and if the LLM will decide if the joke is good or bad. If it is bad, again it will be passed in the loop, and then once it is accepted, then only it will be given as an output. So this is just a basic example. Obviously, this can be refined to a lot more examples. So yeah, let's first understand how this really works. Coming to the code, let us first understand the workflow of it. So I've generated the workflow from Claude. So what will happen is, first we are going to start and then the joke will be generated. Then the process will be passed to the joke evaluator. It decides whether the joke is funny or not based on the input. If it is not funny, it will be rejected, and the feedback will be given based on the rejection, and then it goes to the generator again, and then this process continues until the large language finds the joke to be funny, and if it is funny, it is accepted and the result is given. So coming to the code, first we are going to generate the joke. So here we can see then the basic terminologies and the basic structure of the lang graph remains the same. So this is the first class of state, wherein we store the joke, topic, feedback, and if it is funny or not, all in string formats. Then this class gives the feedback in a structured output, which is funny or not funny, and the feedback is stored in the string format. Now this class is invoked by the evaluator, which generates the result in a structured format. Now, talking about the call generator, what will happen is in the initial state when the call is given, the joke is generated, and if there is a feedback, the prompt that is given is write a joke about the topic, but take into account the feedback as well. So in this state, the feedback is taken. If there is no feedback, then the prompt that is given is write a joke about the topic. So once the joke is written, then it moves on to the evaluator, wherein the evaluator evaluates, grade the joke, and the joke is passed into this the state, as in the state in which joke is stored is passed, and then it returns funny or not based on the feedback. Now, then again, the joke is routed. If it is funny, then it is accepted. Otherwise, it is rejected, and the feedback again flows there. So this flow is controlled, like in all Lang graph models. This flow is controlled by the workflow. First in the workflow, we are going to add the nodes. So this LLM call generator node is added. Then LLM call evaluator node is added, and then we are going to connect the edges. So like we can see, as in the workflow, it is shown the start is connected to the call generator, that is the joke generator over here. So a start is connected to the call generator, then the call generator goes to the call evaluator. So generator goes to the evaluator, and then evaluator evaluates it in a conditional formats. So add conditional edges for that. If it is accepted, then this is the end, and if it is rejected, then again it goes to the call generator to generate it with keeping the feedback in mind. Then it is compiled, and the state is invoked over here. So we'll just check the result as in how the joke is generated. Obviously, we are not going to see this feedback loop in action. We are going to only see the final result, which is the joke. But we can ascertain from this code about the working of the evaluator-optimizer model. So we'll just generate the result of it in a second. So yeah, we can see that the joke is generated, which is a final result. Why do cats always get their way? Because they are persuasive. So again, we really don't know that if it has been sent to the evaluator for evaluation or not. This can again be printed basically in this chain itself. But as of now, we'll not be doing that. We have this is enough for understanding about the evaluator-optimizer model. We'll now move on to understand about the agents. So yeah. Now coming to the last part of our discussion, now we discuss what really agents are. So in the first video, we understood what is the basic difference between a workflow and an agent. Now in the workflow, like we said, a guardrail is used in the code itself to give certain kind of results. So in whatever workflow that we have used, be it parallelization, be it prompt chaining, we are restricting the LLM based on some kind of some kind of restrictive outputs that it can give. So basically, we are giving a guardrail to the LLM to function in some manner. So like in the router method, we were seeing that if the result is out of 1, 2, or 3 options, only then the call will be routed to first agent, second agent, or the third agent. So agent in that sense is a specialized function which is used to solve a particular type of problem. But in an agent per se, no guardrails as such has been provided. So the basic definition of an agent is that agents are simply LLM calls which use tools based on environmental feedback in a loop. So LLM use certain kind of tools to get to a result, and this is what agent is. Now, there is no particular kind of guardrail that can be used for an agent, or there is no scaffolding that can be done for an agent. It is independent in that respect. So that is why agents can be used for open-ended problems where it is difficult to or impossible to predict the required number of steps, and where you can't hard code the fixed path. So agents are typically useful for some kind of complex problems which cannot be really segregated in any kind of workflows that we have been using in the past. So say any kind of tools that we define, and we want to use it in our results. For that, an agent can be used. So this is in a nutshell what the workflow of an agent looks like. An LLM call is given which accesses the tools, and based on the response it then generates an output. So coming to the code, first let us have a look at the graphical flow of how this call is made. So again I've generated through Claude. So what happens is that after the start, the input is goes to the LLM call. Now the LLM call function over here decides if the tool call needs to be made or not. If the tool call is made, then it flows to the environment to access the tools, and then the message plus the result from each of these tool calls is passed to the LLM, and it is a feedback loop over here. Then again, if the LLM decides that then it flows over here. If the LLM decides that no tool call needs to be made, it directly comes over here. So it is completely on the problem solving ability of the input that has been given by the user. So the LLM can decide whether it has to make use of the tools or not. So what we are going to do over here is we will be defining three tools of arithmetic, addition, and division, and these tools are arranged in a dictionary format for to be accessed by the large language model. And in the LLM call, the LLM will decide whether to call a tool or not. With the system message, along with the system message, the state of the messages is passed in this LLM call as well. So this is the feedback loop that is created over here, that we can see if any of the tool, if any of the messages from the tool are passed in this LLM call or not. Now the tool node function again returns the messages as a result basis each of these tool calls, and then a should continue function is also defined, which decides if the loop should be continued or stop based on whether the LLM made a tool call or not. So if the tool call has been made, a feedback loop is provided to call this function again. Otherwise, the result goes to the end and final result is displayed. So in building this function, what we have done over here is we have connected the start to the LLM call. Now LLM call, if the tool call is made, then it is connected to the environment. Otherwise, it goes to the end to give the result, like this call over here. Then we compile and invoke the agent to give the result. So let us see what is the result that we get by invoking this Python file. So the input that we have given over here is the instruction that we have given is add 3 and 4. So let us see what the result is. So we can see that the tool call has been made, and the tool message that is responding is 7 based on the arguments that we are getting over here. So in the tool call, the two arguments are identified as 3 and 4 basis the user's input over here, and then basis the request of the user, we have connected or we have reached for the addition tool, and the tool message that is being given over here is 7. So based on the tool message, the AI message over here, is given as the result of adding 3 and 4 is 7. So essentially, that is what the use of the agent is. The agent uses a certain set of tools to come at a result, and that helps to solve certain complex problems. So yeah, that marks the end of our session over here. So in this whole series, we have tried to elaborate how to build effective agents through different workflows and agent. And hopefully, by watching this video and this series of videos, you would have understood in what particular cases which workflows can be used and in what cases an agent can be used. This is an ever evolving field, obviously, but as of now, it is good if we move ahead with a certain framework in our head to sort of solve problems for certain cases. So, which optimizes how we use the large language model, and it also optimizes our time and effort in achieving other desired results. So yeah, I think that is it for this session. I will see you in the further videos, and please like, share, and subscribe if you are there till the end of the video. Thank you, and yeah, thank you.